per milli. Non-overlapping, overlapping case. Okay. So if you observe here, so this S0, S1 case is common for overlapping and non-overlapping. Okay. S0 and S1 is common for overlapping and non-overlapping case. But when it comes to S2, okay, when it comes to S2, okay. When it comes to S2, okay, so non-overlapping case, even if we get 1 or even if we get 0, we'll go to the reset S0. Getting will go to the reset S0. Now, when it comes to the overlapping case, this case and this case is common, same as a non-overlapping case. When it comes to this third case, okay, so here 1 can be get, 0 can be get, 101, 100, 101. This is our sequence, right? This is our sequence. Okay, output is 1. Okay, when it is 1, so what we need to do? So we need to be check these last 2 bits. These 2 bits is matching with these last 2 bits. First, I need to check. No. So then one step back. This 1 bit is matching with this last 1 bit. Yes. So then I need to go to from S2 to S1. S2 to S1. So if it is not matching here also, then I need to go to S0. Getting? So now after that, okay, there one more chance is there. 1 0 0 1 0 0. So if these two last 2 bits is matching with these two, no. So then one step back. This 1 bit is matching with this last 1 bit, no. So then you need to go to the S0 state. So based on this state diagram, so we implemented the state table. So based on this state table, so we implemented the K maps. Okay. Based on this K maps, we implemented the circuit. Clear? So this is how. So we need to be go step by step. Clear? So this is a Mealy. Any questions? Any doubts in Mealy? I will tell you more also. After that, so we'll see the different kind of question, different kind of experiments. Clear? So keep a heading more. 101 sequence in more. Non-overlapping case. 101 sequence. So in more. Non-overlapping. Non-overlapping. Yeah. So 101 synchronization using more missions, non-overlapping. So now, so if you observe here, so I already told when the difference is, okay, n bit, n plus 1 states are required in the more missions. N bit, n plus 1 states are required in the more missions. How many bits are there? 101 sequence detection, 3 bits are there, right? So how many states are required? 4 states are required. So what are those? S0. Now the indication, see here the output will be depends only on the present state, right? So the output will be depends on only present state S0 by 0. Generally, previously the output will be depends on the Venn state diagram. So whatever input is we are giving based on the input, output will depends. But here the output will be depends on the state. Okay, output will depends on the state S0 by 0 because sequence is not detected at S0. Okay, so next S1 by 0, S2 by 0. Next S3 by 1. Here sequence is detected. 4 will becomes 4 states will comes. Previously we see only 3 states for 3 bits. Now 4 states will see. Okay. So now S0 there are two chances are there. S0, we can get a 0 input or 1 input. 0 input, 1 input. If 1 input will get, that is the required sequence, okay? I will go to the next step. 1 will get. So here we will not indicate any zeros or ones. The only input will be there. Difference, state diagram difference. Here only input will be represent. In the state inside will represent the outputs. This is 0, this is 0, this is 0. When come to the S3, it is 1. Clear? So if 0 will comes, where we need to go? 0 will comes, okay, that is not our sequence detection. I need to be stay in the same state. Stay in the same state when 0 will comes. Now this S1 already detected. Already detected 1. So now we have two chances. After this 1, we can get a 0 or we can get a 1. So if 0 will get, what I will do, that is the required sequence 1. After that 0 we are getting. So I will go to the next state. Okay. So this is 0. This is 0. Okay. So if 1 I am getting, where I need to go? So if 1 I am getting, what I need to do? This bit I need to compare with this bit. Both are matching? Matching. So then I need to stay in this. If it is not matching, then I need to go to the S0 state. If it is matching, so then I need to stay here. So the input is 1. The input is 1. So now at S2, so you need to come to the here what already we detected 1 0, right? 1 0 already detected. So now after this, what we can get? Either we can get 1 0, 1 0 0. Two cases will be there. So now 1 0 1. 1 means that is the required sequence 1 0 1. So I need to go to the next step. So 1 means I need to go to the next step. So if suppose 1 0 0 we are getting, so then what I need to do? So I need to compare these two bits with these last two bits matching. No. So then I need to compare this last bit with this last bit matching. No. So then I need to go to the directly S0 state. From here I need to go to the, so when it is 0, input is 0. Clear? So after this you observe. So next what we have? Next already we detected 1 0 1, right? 1 0 1 at S3. So now input will be 1 0 1. After this we can get 0 1 0 1. After this we can get 1. Two possible cases will be there. Okay, two possible cases will be there. In the non-overlapping case, remember, I am again saying in the non-overlapping case, you no need to be checked. Okay, these three digits with these 3 digits. Okay, no need to check. Only you need to check the after sequence detection. What is the extra bit is there? That only one extra bit you need to be checked with the. Okay, so this is 1 bit, right? Last extra bit. 1 0 1. This is the sequence. This one is completed. This whatever the extra bit is there, this extra bit you need to check with this one. That's one step. Matching? No. So then what you need to do? So when this one 0, so what I need to do? I need to go to the S0. S0. Getting S0. So after this non-overlapping case, I am again saying, after the sequence detected, whatever the extra bit is there, that only one extra bit you need to map. You should not go, okay, 1 or 3. So this I 1 0 1. Here also 1 0 1 I will check. After that 1 0. Here 1 0 I will check. No. Only you need to check this last bit. In the millimeter, you will not check at all. Non-overlapping case. Yes, so even 0 input or 1 input, you will go both cases, go to the S0. Okay. In the overlapping case, you will check okay, 3 3 2 2 like that you will check. But in this Mealy mission non-overlapping case, you will check only last bit. Getting that summary I will give. Don't worry, you will get that summary. Okay. So this last bit you will check. This last bit when you are checking, okay, you will check with this as one. Last bit means one bit, right? One bit stored here only, right? So you will check with this one, it is not matching. So then you will go to the S0 square. So now, so this case, if one will get this last bit is matching with this one, S1, yes, right? So now I need to go from here to here. Clear? This is the non-overlapping case. This is the non-overlapping case. If you understand non-overlapping, overlapping very easy. No doubt.
Why we have written 0, 0?
Sorry?
Below the space. Why we have written 0, 0?
This one, huh?
Yes.
See, when I told the differences between Mealy and Moore, okay? So what I told in Mealy, the output will be depends on present state as well as present input. Present state as well as present input. So that's the reason when I am implementing Mealy state diagram, okay? So what I did, okay? So the output will be depends on present state as well as present input. Then output will go right here only, okay? Here only. But when come to the Moore missions, what is the definition I told? The output will be depends only on present state, not on the present input. Not on the present input. Means, see, the state only tells that okay, output will be 0 or 1. So now here the 0, we are getting 101 sequence. No. We are getting it at 0, 101 sequence. No, right? S1, we are getting 101 sequence. No. S2, we are not getting S0, 101 sequence. At S3, we are getting 101 sequence. After that only extra bit is coming. Yes or no? So that's the reason this S3 when we are getting, okay, that state will be 1. No doubt. Clear? So when you are reaching to S3 means you already detected the 101 sequence. That's why inside the state only it will represent. That is the small differences between the Mealy and Moore. Clear? So now we'll see 101 sequence detection. Using Moore overlap. With overlap, how it will be seen. So now how many states 101 means? No doubt 4 states will be there. 4 states. As you see, diagram you can draw any. See, I am drawing horizontally. So people will think only horizontally we need to draw. Only continuous like this only we need to draw. No, it's not like that. You can draw any type. I will show you. This is S0 by 0, S1 by 0, S2 by 0, S3 by 1. 4 states are required, right? 4 states are required. Now S0, when it is 0, what I need to do? For explanation, it will be clear. That's why at the bottom I kept. Okay. When come to the S1, so there are 2 possible inputs are there. 0 or 1. 0 or 1. If 1 will comes, that is the required sequence. I will go to the next step. 1 will comes. If 0 will comes, that is not a required sequence. I need to stay there only. I need to stay there only. Yeah. So now, so at the S1, so I have again 2 possible cases. already we detected 1. Okay. So now we have two possible cases. If 0 will come, so S1. So I am writing here. So S1 already we detected 1. So now we have two possible cases, 1 0 or 1 1. Okay, 1 1. So if 0 0, that is the required sequence detection, I will go to the S2. Okay, if it is 0. If it is 1, it is 1. So that is the required sequence. No. So now what I need to do? I need to compare this last bit with this bit. It is matching. Matching with S1 bit only, it is matching. So then I need to stay in the same. When it is 1. When it is 1. Clear? So now come to the S2. S2, what I already be detected? 1. 0 we already detected. After this, 1 0. 1 we can get, 1 0. 0 we can get. Clear? 1 0 0 we can get. So now, so if 1 will get, that is the required sequence. Okay, 1 0 1. That is the required sequence. I will go to the next state. So if 1 0 0, so that 0 means that is not a required sequence. What I need to do? I need to check these two bits with these two bits matching. No, this one bit with this one bit matching. No. So then what I need to do? I need to go to the from S2 to directly S0. S2 to S0. Getting? So when sequence is when input is 0. When input is 0. So now next at the S3, what we already detected 1 0. 1 we already detected means output is generated to 1. Clear? So now after this 1 0 1, after this we can get 0. 1 0 1, after this we can get 1. Now previously what we did, last only one bit we compared. Now it's not like that. Now we need to compare this last 3 bits with this last 3 bit matching. No, this last 2 bits you need to compare with this last 2 bit matching. Yes. So now from S3 to where I need to go? S2 when we are getting 0. Getting when we are getting after this 1 0 1, after again we are getting 0, we need to go to the S2. Okay, from S3 to we need to go to the S2. When input is 0. Input is 0. If input is 1 1 0 1, after this 1 is getting. So then what I need to do? I need to compare this 3 with this 3 matching. No. Last this 2 I need to compare with this 2 matching. No. So last this 1 I need to compare with last this 1 bit matching. Yes. So means from S3 to I need to go to the S1. From S3 to I need to go to the S1. I will draw like this. S3 to S4. This is 1. Clear? So like that you need to draw. This is the overlap. With overlap. With overlap, we will check all the bits. Non-overlap, okay, in the melee, only last bit you will check. Okay, in more last bit you will check. In the melee, when come to the melee, so what you will do? So non-overlapping case, after the final state, you will go to even 0 will comes, 1 will comes, it will go to the S0. So overlapping is same like how the more you are checking, the same overlapping is same you will check in the melee also. Clear? Simple. If you are able to draw this state diagram, state table is very easy. What is the state table of this one? Someone will ask, what is the state table of this one? Simple. What you need to do? Present state, input, next state, output. That's it, right? Present state, input, next state, output. What is the present state we are getting? So present state, what is this? S0, right? When S0, so it can be 0. When S0, it can be 1. When S0 it is 0, I need to go to the S0 only. S0. Output will be 0. That will later will write. Okay, S0. If 1, I need to go to the S1. So S1 also two cases will be there. 0 and 1. So if S1 0, so then I need to go to the S2. If S1 1, I need to go to the S1 only. S1 only. Then S2, two cases will be there. S2. S2 0. S2 0, I need to go to the S2 0, I need to go to the S0 state. S0 state. So S2, if it is 1, I need to go to the S3 state. S3 state. So now S3 we have two cases. S3, S3. This is 0, this is 1. S3 is 0 case, I need to go to the S2 state. In this whatever we are drawing for the table with the overlap, okay? So S2 state. S2. So S3 with the S3, if it is input is 1, so then I need to go to the S1 state. S1 state. So now see. So this state, okay, 0 state, what is the output? 0 state, S1 both are 0. What is the output? 0 state, 0, right? This one you need to check this one. You need to observe this one. What is the output? 0. 0. In both cases, 0. So S1 state, what is the output? S1 state, what is the output? 0. S2 state, what is the output? 0. S3 state, what is the output? 1. Yes or no? In respect of inputs, output will be depends on only state. This is 1 1. Clear? This one you need to convert next into the binary table. So how we will convert this one into the binary table? It's simple. Present state, input I, next state, output. So now present state, so you can represent Q2, Q1. So next state, okay, so input I is same I1 you can represent. So next state, this is also Q2, Q1. Output you can represent by or Z, anything is fine. So now, so in place of S0, you need to replace with 0 0, S1 0 1, S2 1 0, S3 1 1. Clear? Clear. So 0 0 0, two cases are there, right? So these both 0 0 0 or one case will be there. 0 0, it will be 0 0. So 0 0, it will be next case is 1, right? So next I need to go. So this is 0 1. Okay. So now next these outputs are 0. Next 0 1, two cases will be there. 0 1. So 0 1. 0 1, if 0, I will go to the 1 0. 1 0. So 0 1, if it is 1, 0 1 only. 1 0 1 0. 0 1 0, if it is after that 0, so it will be 1 0 after that 0. See, 1 0 after that 0. 1 0 means this one, right? 0 is 0, right? 0 0 0 0. 1 0 after 1. Sir, no. 1 0 means S2. S2 0 0. S2 1 S3 1 1 1 1. So next 1 1 1 1, 0 case will be there. 1 case will be there. So no, 1 case will be there. 1 1 0 1 0. 1 1 1
Zero.
0, 1. Output will be 1, 1. So now, so which flip-flop you are using? So I will suggest you that go with the D flip-flop. Very simple. So go with the D flip-flop. Whatever Q2 is there. So next step Q2, next step Q1 will be the same. Okay. So flip-flops D1, D0. So what is the output here? 0. So you need to check this one. This Q2. So 0, 0, 1, 0, 0, 1, 1, 0. Clear? This is how I am drawing this acceleration table. If someone will say JK flip-flop, you need to check 0, 0. What is the JK excitation table? Based on that excitation table, you need to draw here. Getting? So next here 0, 1, 0, 1, 0, 1, 0, 1. Clear? So what is the K map? If you see the K map, D1. So what are the inputs we have? Q2, Q1, I. 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Clear? 1, 0. So now, so you need to check when it is high. It is high at this condition. Yes or no? It is high at in this condition. What is this condition? This is 0. This is 1. This is 2. This is 3. This is 4, 5, 6, 7. So this condition it is high D1. So what is this condition? 2, right? Yes or no? 0, 1, 0. 0, 1, 0. This condition it is high. So next, when it is high at 5. 5 means 1, 0, 1. In this condition it is high. After that, when it is high at 6. 6 means when 1, 1, 0. This condition it is high. So no. Any other cases it is high? No, right? So this is the thing. So I need to be map. So what is the maximum possibility of mapping here? 2. These 2 I can map, right? This I can't map. This individually I need to map. This when these 2 I map, so Q2 is not common, but Q1 I bar is common. Q1 I bar plus Q1 I bar plus. So this one I need to map. What is this? What are the commons in this one? Q2, Q2, Q1 bar, Q1 bar I. So no. Q2, Q1 bar I. This is the D1 equation. So this one, see. So one how I am mapping is Q2, Q1 bar I. Clear? So this is D1 equation. Now come to the D2. Sorry, D0. 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 Q2, Q1, I 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So now you can see. This is okay 1. We are getting. So when it is high at 1, 0, 0, 1 case. 0, 0, 1. In this case it is high. So next at 3. 3 means 0, 1, 1, right? At 3 it is high 0, 1, 1. In this condition it is high. So next it is high at 5. In this condition 1, 0, 1 it is high. So next it is high at 7. In this condition maximum how many mapping is possible? 4 mapping will be possible. This 4 if I can map. What is the common in this 4? This Q2 is not common, 0, 1 it is changing. In this what is the common? Q1 is 0, 1 it is changing, but I is common. So now D0 equal to I. D0 equal to I. Clear? So now output by also need to be implement the K map. So no need to implement the K map directly. You can see by output. Okay. So when inputs are both are 1, 1, so outputs are changing also. both are 1 1, then output is high. If you want to directly, you can go. Otherwise, go with the K map only. No problem if you go with the K map also. Q2, Q1, high. So 0 1, 0 0, 0 1, 1 1, 1 0. So when it is high, 1 1, 0 case, it is high. 1 1, 1 case it is high. 1 1 0 means this one, right? Yes or no? 1 1 0. 1 1 1 means this one. These two mapping, what is the common in these two? What is the common in these two? Q2, right? Q2. What is the common in these two? Q2. So in this, what is the common? Q1. Q1, right? So directly from here itself, okay, these both are high, these are changing. So Q1, Q2, Q2, Q1, you can directly take from here also. Or you can implement the K map also, not a problem. But remember, always remember, I already told, okay, in the output, when it is melee, so in the output should not comes I. Should not comes I. If I is coming, means you did something wrong. In the output should not comes I. But when come to the melee state, so in the output, what we will get? Where is the y? Y equal to Q1, Q0 bar I. Here I will comes in the melee state. More steps should not comes I. Clear? So that's what we when we discuss the differences. See, this input is directly connected to output combination. That's why I will comes. But here input is not connected to output combination. I should not come. If I is coming means you did something wrong. Clear? So this is the equations we got finally. So now I need to implement the state table. So see, so previously I drawn the flip flops. Okay, so one after other. So you can draw like this also. Different peoples will represent different ways. So you can represent like this also. This is also not a problem. B0, Q0, Q0 bar, B bar, Q0, sorry, Q1, Q1 bar. So now clock is common. Clock is here, clock. So now, if you observe, so for D1, Q1, I bar, Q2, I1 bar, I. Okay. So Q1, I bar. For suppose consider this is I. For D1, you are taking this. So I bar Q1. Q1 will comes from here only, right? Yes or no? This I need to do one on the gate. After this one is completed. This section is completed. So now Q2, Q1 bar, I, Q2, Q2, sorry. Here I represent it as Q2, Q1. So change it to, okay, in equation also I represent it Q2, Q1. So then, okay. Clock sequence represent, this is Q1, this is Q2, Q2 bar. Sorry. So then it will change. I represent it like this. That's why I'm taking like that. Okay. So yeah. Q1 I bar. This is for D1 only, right? So this is for D1. Okay. So this is the Q1 bar. So this we need to take. Right here. This is the thing. So next, So Q2, Q1 bar I. So Q2, this is the Q2. Q2, Q1 bar. This is the Q1 bar. Q1 bar, Q2, Q1 bar. So next, this is the I. These three together, 108 video. So after this, okay, we have R between these two. R we have. So I need to go with R. This one. This one together, R. So then I need to connect to D1. Clear? So this is the thing. For D1. So now come to the D0. What is the input? Directly I. Connect directly I to D0. So now output also I need to be taken, right? Output, what is the output? Q2, Q1. Output is Q2, Q1. This one and this one. This is the output. It is Q2, Q1. This is the output. Any questions, any doubts here? Any questions, any doubts? Try to draw by one. Then you will understand, okay, how much concept you learn. Okay. See, efficiency. I did many jobs. These all things I did, right? So you can directly draw. So if you feel this is a difficulty, so directly okay, remove these all things and represent inputs here. That is also fine. Clear? See, state diagram will be comes, okay, in delay or more, if you know state diagram properly, so the representation of state table and circuit diagram will be very easy. Clear? So now we'll discuss after this complete, after your note down is complete, then we'll discuss summary of this, okay, Millet and Bohr state diagram, okay. Clear? So can we go to the summary? What is the summary? So coming to the summary, okay. So when we implemented this state tables, okay. So two cases are there, right? Relay, two cases are there. Map, overlap. More. Non-overlap. Overlap. Yes, overlap. So now, overlap is there. So now if you observe, so this whatever Millet non-overlap case, okay. all up to final state, it will be same. When come to the final state, non-over, yeah? So what you need to do? So you need to go to the S0 state. You need to go S0 state when reach final state. Reach final state. So whether input is 0 or 1, input 0 or 1, need to go S0 state. This is the state. S0 state when you reach final state. When you reach the final state. So whether 0 or 1, and in the final state, you will go to the reset S0 state. So in the overlap case, we will compare first 3 bits with 3 bits. Okay. Compare 3 bits with 3 bits, then 2 bits with 2 bits, then 1 bit with 1 bit. Clear? 2 bit with 2 bit, 1 bit with 1 bit. This is the overlapping case. When come to this non-overlapping case, in the final, see whatever I'm talking is all things related to final state. Okay, final state. This is also a final state. At final state, not only like this. Final state. Compare 3 bits with 3 bits, 2 bits with 2 bits, 1 bit with 1 bit. Clear? So next, non-overlapping case. In this, what happened? At final state, only compare last bit. Only compare last bit with only compare last bit with only compare last bit with what? With the S1 state. So now with the last bit with S1 state. This is S1 state. Why this pen is not open? S1. This S1 state. S1 state. So here same. At final state, compare 3 bits with the 3 bits, 2 bits with 2 bits, 1 bit with 1 bit. Clear? So then this is the final state diagram. And one more thing you need to be remember that, okay? So in the Mealy emissions, output will be depends on the input. So output equation will get the input I also. But in coming to the Murray emissions, output not depends on the input. Output equation, output combinational equation should not come the I. If it is coming I means it is wrong. Any questions, any doubts? So yeah, I think they told me to be take one section, batch up to 8. Maybe after that, Raghu will become and we will continue. Yeah. So digital, almost all the topics are covered. Any topics are okay, not covered, or any topic is missing, please let me know. Because we have tomorrow and day after tomorrow session, 2 sessions will be there. Okay. So if any topic is missing, please let me know. We'll discuss those topics. you can send in the group that these topics are missing. Okay, so we'll discuss. So otherwise, I will repeat the same topic one more time. Different state diagrams you will see. Otherwise, if there is no topic is missing, so then different state diagrams. Okay, 0 0 0. How state diagram will increment? Okay, 1 0 1 1.